So I was working my way slowly through the details of a derivation of the expression for quantum interference. The steps consist of the following. Writing the equation for probability amplitude. Expanding the right side using the properties of the complex conjugate. Grouping terms. Converting to exponential form and grouping again. And then applying a trig identity to get rid of the exponential notation. Straightforward, but lots of math. Then it occurred to me that with a judicious choice of trig identities, it is possible to get the same result more intuitively and with far fewer steps. So here we go. Let's say that there is some two-outcome situation to which probabilities can be assigned. Imagine, for example, that there is a 60% chance of showers by noon. Let's call the probability of rain by lunchtime. And the probability of no rain by lunchtime. Since these are the only two possibilities, and since in this context, the phrase probabilities are scalar quantities, of course, but as a thought experiment, let's say that they correspond to an analogous set of 2D vectors, related to each other in a similar fashion. Using the Greek letter psi to represent these vectors, we could write We also need to specify how exactly p relates to psi. Well, the length of a vector is a scalar, so we could define each vector such that its length equals the corresponding probability value. In fact, it turns out to be more convenient to equate the length of each vector to the square root of the corresponding probability. In other words, is there anything else that we can say about these vectors? We know that the two component vectors on the right add to give the resultant vector on the left. Can we specify the relationship between these component vectors? In other words, the angle between them. Well, we know that for the general case of two component vectors that add to give a resultant vector c, where the cosine rule states that note that the relative angle between the vectors is given not by gamma but by pi minus gamma. And using another trigonometric identity, The expression can be rewritten as returning to our original set of vectors, we can substitute as follows. Which means that or which is identical to the expression for probability on the Wikipedia page for probability amplitudes, in the section on the double-slit experiment. Note that corresponds to the classical notion of probability, and that the last term describes the impact of quantum interference, which can either be positive or negative depending on the angular difference between the component vectors. QED